Hi, this is Dr. Alexi. I've created a small program to demonstrate the Inlet Viewer queue mechanism. Now basically, the queue mechanism is a form of a storage buffering device in Inlet Viewer. It's a very powerful tool that can be used, especially if you try to communicate between several loops, such as while loops, for example. So without further ado, let's dive straight into this program. On the left hand side is the front panel. On the right hand side is the block diagram. Now the main idea is that I would like to send some random number generated and the first while loop at the top, and displaying that data on the waveform chart 1, as you can see over here. Now this random number that is being generated is pushed into a queue function, which I will explain a bit more detail shortly. And at the bottom loop here, while loop number 2, I will be able to also have a copy of that data that is being sent to the waveform chart. So now without further ado, let's have a run of this program to take a look at the output. Let me click on the run function. Now what you can observe is that the two waveform chart, there is a waveform chart number 1. This indicator is residing in the loop number 1. And the second waveform chart 2, the chart is actually residing in the while loop number 2. Now, if you observe carefully, both of these charts have identical values that is being passed from at the waveform chart 1 as well as waveform chart 2. They have identical values. Alright, so let's take a look. Allow me to switch you over to the block diagram and let me turn on the highlight execution. Now what you can see is that how the program behaves is this. Now we have used the queue mechanism, and this function is called the obtain queue. Now I will show you later on where we can find or locate these functions. So this is the initial part called the obtain queue. So what happened is that you in Inlet Viewer you are creating a queue channel, okay, or a mechanism, and I named this queue called my queue. Alright, and also I would need to define the data type that is going into this particular queue. So in this case, this particular queue holds the data type, which is a floating number. Okay, now so in this while loop number 1, it should not be too surprisingly for all of us here. I've used the random number generator to generate a random number. Any number between 0 to 1 is being generated here. Now this data is passed into the waveform chart 1, and the data gets displayed on the front panel on your left hand side. And at the same time, this random number is also push into this function called the enqueue element function, right? So at the beginning, right, when we obtain a queue or we created a queue, this is the queue reference for this particular queue. Now every queue is unique, every queue is different, and every queue has a reference, queue reference. So you see this line here, greenish orange color, right? This is the queue reference for this particular queue that we have created called my queue, right? So this value gets inserted into the enqueue element function. Now if we to examine the second while loop at the bottom, now while loop number 2, now notice that we have so-called Inlet Viewer, we fog the wire. So fogging, and that means you kind of like split this queue reference over here. So we are also taking a reference from the top here. The same queue that is coming down here is being passed to the second while loop here. Now in the second while loop number 2, I've used another function called the dequeue element function, right? Now what happened is that because his point is referencing to the same reference queue, so what gets inserted into the enqueue element here, the same value will be dequeued and extracted, okay, out from this dequeue function and then push it into this waveform chart number 2 as shown over here. So if we were to run this program in highlight execution mode, you can see and observe very clearly that the values are being passed from one loop to the next loop. Alright. And also in each loop I've introduced the wait millisecond. So in this loop is running at 100 millisecond interval. Alright, so let me stop the program and show you where I can obtain these queue functions, if you like. At the same time, one more thing that I forgot to mention is that at the end of the function that you use, right, the queue function, you need to do a release queue. Release queue will ultimately destroy this particular queue when it's not in use, to free up the memory space, right? So of course, and I also have a stop button here. Now the queue functions can be located in this palette. So if I right click on my mouse, okay, I'm going to navigate to this palette called the synchronization palette. Synchronization palette. Under the synchronization palette, you will notice that you have a few things. You have notifiers, queue, semaphores, rendezvous, occurrence, and so on. So I'm looking at the second one, which is called the queue operation. So let's move in and take a look. So this is the function that I was referring. So allow me to zoom in a bit. Now under the queue operation, there are different functions that we can locate. You have the first one called the obtain queue. The second one, the first row, second column is called the enqueue element. You have the enqueue, you have the dequeue at the bottom, preview, and other functions as well. We also have the release queue. So these are the queue functions that you can explore and use. But namely in this part of the module, we also will only be concentrating at using the enqueue element. Alright, enqueue means you put the element into the queue. And at the bottom here, as I've demonstrated, we use the dequeue function. Alright, the dequeue function is to extract the element from the same queue. Alright, so this is just a very simple program that you can explore. Right, so I will pause my recording here. Thank you for watching.